Physics Part 416. And now we talk about CT scanning, computed tomography, CT scanning, computed tomography, CT scanning. Oh, by the way, it's not CT scanning. Most of the people do pronounce it wrong, take the wrong words for it. It's CT scanning, computed tomography, CT scanning. The image produced on X-ray film is outlined earlier in a shader or flat image. There is little, if any, indication of depth. That is the position of an organ within the body and is not apparent. Also, soft tissues lying behind the structures that are very dense cannot be detected. Tomography is a technique whereby a three-dimensional image or slice through the body may be obtained. The image is produced by computed tomography using what is known as a CT scanner. An example of such an image is shown in the figure. In this technique, a series of X ray images obtained. Each image is taken through the section or slice of the body from a different angle, as illustrated in the figure. Data for each individual X ray image or angle of viewing is fed into a high power computer. The computer enables the image of each slice to be combined so that a complete three-dimensional image of the whole object is obtained, which can be then viewed from any angle. The basic principles of CT scanning may be illustrated using a simple cubic shape, as shown in the figure. The aim of CT scanning is to produce an image of a section through the cube from measurement made about its axis. The section or slice through the cube is divided up into a series of small units called voxels. Each voxel will absorb X-ray beam to a different extent. This intensity transmitted through each voxel alone can be given a number, referred to as a pixel. The various pixels are built up from the measurement of the X-ray intensity along different directions through the section or slice. Suppose that the cube in the figure is divided into 8 voxels. The cube can be thought to consist of 2 slices or sections. For the first section, let the pixel be shown in the figure. The purpose of CT scan is to reproduce these pixels in their correct positions. When the X-ray beam is directed in the section from the left as shown in the figure, the detectors will give readings 7 and 13. The voxel will partially completed. The voxels will be partially completed as shown. The X-ray tube and the detectors are now rotated through 45-degree. The new detector readings are 4, 8 and 8. These readings are added to the readings already in the voxels as shown in the figure. After rotation through a further 45-degree, a third set of the detector reading is taken. These readings are added to a voxel reading. The result is shown in the figure. After rotation through a further 45-degree, a final set of readings is taken. Once again, the readings are added to those already in the voxels, giving the result shown in the figure. The resulting pattern of the pixels is shown in the figure. Having summed all the Bayer, it remains to reduce these measurements to that of the original. This is achieved in 2 stages.